Hello everyone. So now we are going to understand one of the most important concept in artificial intelligence, which is knowledge representation, commonly called KR. Before we understand the definition, let me ask you a simple question. Suppose if I ask you, can birds fly? Most of you will immediately say yes. Now, if I ask, can penguin fly? You will probably say no. How did you answer these questions so quickly? Did you search the Google? Did you perform any calculation? No, right? So our brain already has this knowledge stored, and it also knows that while most birds can fly, penguins are an exception. This ability to store knowledge and use it to answer questions is what makes humans intelligent. Now, imagine asking the same question to a computer. A computer doesn't naturally understand the word like humans do. It only understands the data, numbers, and instructions. So, if you want a computer or an AI system to answer these kind of questions intelligently, we first need to teach it by storing the knowledge in a structured way. So, this is where the knowledge representation or KR comes into the picture. Knowledge representation is a branch of artificial intelligence that focuses on how to represent information and knowledge in a format that a computer can understand, reason with it, and use to solve the problems. In simple words, knowledge representation is like building a knowledge library for an AI system. Instead of just storing random information, we organize facts, relationship, rules, and concepts so that the AI can use them whenever it needs to make a decision. So, for example, we can store knowledge like this. A bird is an animal. Most birds can fly. A penguin is a bird. Penguins cannot fly. Now, if someone asks the AI, is penguin is an animal? It can reason through the relationship. Penguin is a bird, bird is an animal, therefore, a penguin is also an animal. This process of using stored knowledge to arrive at a new conclusion is called reasoning. And it is one of the main goals of knowledge representation. So remember, knowledge representation is not just storing information, it is about storing the information in such a way that the machine can understand it, connect different pieces of knowledge, make logical decisions, and solve problems much like humans do. So, for example, think of a Google map. Okay, think of a Google map. It doesn't just store the names of the cities, it also stores roads, distances, traffic condition, speed limit, and alternative routes. Because all this information is organized properly, Google Maps can quickly suggest the best route to your destination. Similarly, knowledge representation organizes knowledge so that AI can find the right answer or make the best decision. So, why do we need it? That means, why do we need this knowledge representation? Why can't computers simply store the information and answer our questions? Let's understand this with a simple example from our daily life. Imagine you are about to leave home in a morning. You look outside and notice that it's raining. Without much thought, you decide to take an umbrella. Did someone explicitly tell you to do that? Probably not. Your brain or our brain automatically connects two pieces of knowledge. It is raining, an umbrella protects you from getting wet. But based on these facts, so we make a decision. This is how humans think. We continuously use our knowledge and experience to make decisions without even realizing it. Now, let's look at a computer. A computer doesn't have common sense or life experience. Even if it knows that it's raining, it won't automatically understand that it should carry an umbrella unless we explicitly represent that knowledge in a way the computer can understand. This is exactly why knowledge representation is needed. By representing knowledge in a structured and logical format, we enable computers to think in a logical way and solve problems. Knowledge representation helps AI system do three important things. The first, understand relationship between facts. For example, a dog is an animal, Bruno is a dog. The AI can understand the relationship that Bruno belongs to the category of animals. Second, infer new facts. This means discovering new information from existing knowledge. For example, if the AI already knows every employee has an employee ID, Ramesh is an employee. Even if we never directly say Ramesh has an employee ID, the AI can logically infer that information. Third, make decisions. Suppose an autonomous car detects a red traffic signal, the AI already knows the rule. If the signal is red, stop the vehicle. Based on this stored knowledge, the AI immediately decides to stop. This is how self-driving cars and many intelligent systems works. And now, how does a computer understand the same idea? Instead of English sentences, the knowledge is represented using logical notation. We write human as X and mortal as X. This simply means if X is a human, then X is a mortal. Next, we write human is Socrates. This tells the AI that Socrates belongs to the category of humans. Using logical reasoning, the AI automatically concludes mortal is Socrates. This process is called inference. We never explicitly stored the sentence Socrates is mortal. The AI generated is new knowledge on its own by applying logical rules. This ability to derive new facts from the existing knowledge is one of the biggest strengths of knowledge representation. So, for example, think about a medical diagnosis system. The AI already knows these facts. If a patient has a high fever and cough, they may have a viral infection. So, for example, Ravi has a high fever. Ravi has a cough. The AI combines these facts and infers that Ravi may have a viral infection, helping the doctor make faster decisions. Similarly, recommendation systems, chatbots, autonomous vehicles all rely on knowledge representation and logical reasoning. Now that we understand what knowledge representation is and why it is important, now let's look at the different types of knowledge that AI system can store. Just like humans don't store every piece of information in the same way, AI also categorizes the knowledge into different types based on its purpose. There are 5 major types of knowledge that are commonly used in artificial intelligence. So the first one is the declarative knowledge. Declarative knowledge is all about facts. It tells us what is true about the world. Think of it as information that you can simply state or declare. For example, Paris is the capital of France. The earth revolves around the sun. Water boils at 100 degrees Celsius. These are all facts. They don't tell us how to do something. They simply describe reality. In AI, declarative knowledge is stored as facts or statements that the system can use whenever needed. Second one is procedural knowledge. Unlike declarative knowledge, procedural knowledge tells us how to perform a task. It consists of steps, methods, or procedures. See, for example, how do you make a cup of tea? The first step, what we are going to follow is boil the water. The next, we are going to add the tea powder. And next, we are going to add milk and sugar. And the next step is serve. These are some of the procedures we are going to adopt. Similarly, when you learn to ride a bicycle, drive a car, or solve a mathematical problem, you are using procedural knowledge. And in AI, procedural knowledge helps systems perform tasks step by step. See, one more example, if you take a navigation app, it doesn't just know the destination. It also knows how to reach it by following the roads and direction. That's procedural knowledge. The next type is semantic knowledge. This semantic knowledge is about understanding the meanings, concept, and relationship. It helps AI understand what different words and objects mean. The AI learns the relationships like dog is a type of animal, apple is a type of fruit, teacher is a profession, and this helps AI answers questions more intelligently. In simple example, if I say a lion is an animal, AI understands that a lion belongs to the category of animals. This understanding of concept is semantic knowledge. The next type is meta knowledge. So this sounds a little confusing at first, but it's actually a very simple one. Meta means about itself. So meta knowledge means knowledge about knowledge. It helps an AI understand what it knows and what it doesn't know. Imagine someone asks you, what is quantum computing? You may say, I know a little bit about it, but I'm not an expert. So you are actually evaluating your own knowledge. That is meta knowledge. So an example, one more simple example is, suppose an AI chatbot receives a medical question that is not confident about. Instead of giving a wrong answer, it says, I don't have enough information, please consult a doctor. The AI knows the limit of its knowledge. That's meta knowledge. The fifth type is heuristic knowledge. Heuristic are simply rules of thumb. Okay, so heuristics are simply the rules of thumb. These are not guaranteed to be correct every time, but they work well in most situations because they are based on experience. Humans use these heuristic every day. For example, if the road is wet, drive slowly. Usually, this is a good advice, but maybe the road is wet because someone washed it, but not because it's raining. Still, slowing down is generally the safer decision. That's heuristic knowledge, which is based on the experience. And if you take one more example, okay, so if traffic looks heavy, choose another route. If your phone battery reaches 20%, charge it. If a patient has a fever and cough, it may indicate a viral infection. And these are experience-based decisions rather than strict logical facts. So let's quickly summarize all the five types. Okay. So declarative knowledge tells us what something is. Procedural knowledge tells us how to do something. And semantic knowledge explains the meaning and relationship between this concept. And meta knowledge tells us what we know and what we don't know. And the last one, heuristic knowledge, is based on experience and practical rules of thumb. Each type plays a different role, and together they help AI system become more intelligent and capable of solving real world problems. So, what makes a knowledge representation system good? Imagine you are building a library. If books are scattered everywhere, it's very difficult to find information. But if the books are organized properly, you can quickly locate what you need. Similarly, in artificial intelligence, it's not enough to simply store the knowledge. The knowledge must be organized in such a way that the AI can understand it, reason with it, and update it whenever the new information becomes available. A good knowledge representation system has four characteristics. So let's understand the one by one. The first one is representationally adequate. The first characteristic is representational adequacy. In simple word, it means that the system should be able to represent all the knowledge that is required. Think about a hospital management system. It should be able to store the information about the patients, doctors, medicine, diseases, and also appointments, test report, etc. If the system cannot represent one of these important pieces of information, then it is incomplete. Similarly, an AI system should be capable of representing facts, objects, events, relationship, rules, and even uncertainty when necessary. So, representationally adequate means the system should have the ability to express every type of knowledge needed for solving a problem. The second characteristic is inferential adequacy. Now, storing knowledge is not enough. The AI should also be able to think logically and derive new information from the knowledge it already has. Let's revisit The famous example, suppose the AI knows all humans are mortal, Socrates is human. Even though we never explicitly told the AI that Socrates is mortal, it should be able to conclude that fact on its own. This process is called inference. So, inferential adequacy means the knowledge representation system should support logical reasoning and allow the AI to infer new facts from the existing one. This is one of the key reasons why AI appears intelligent. The next one is inferentially efficient. Second one is inferentially adequate. That is different. So the next one is inferentially efficient. This is different. So let's see. Imagine you are using a Google map to find the fastest route to your destination. Would you be happy if it took 5 hours just to calculate the route? Of course not. The answer should come quickly. Similarly, an AI system should not only reason correctly but also reason efficiently. It should arrive at conclusions in the shortest possible time using the least amount of computational resources. See, for example, if you ask ChatGPT a question, you expect an answer within a few seconds, not after several minutes, right? So this is possible because the underlying systems are designed for efficient reasoning. So inferential efficiency means the AI should be able to perform reasoning quickly and efficiently. The next type is acquisitional efficiency. Okay, so the word is constantly changing every day, right? So the world is constantly changing. So every day, new discoveries are made, new products are launched, and information becomes available. If an AI system cannot easily learn new knowledge, it will soon become outdated. Therefore, it should be easy to add, modify, or update information whenever required. So these four characteristics are very, very important in case of knowledge representation. So only when all these characteristics are present can an AI system becomes reliable, intelligent, and practical for solving the real problem. Okay. So now that we have learned what knowledge representation is, why it is needed, and what makes a good AI system, let's move on to the next important topic, that is how do we actually represent knowledge inside an AI system. So just like there are different ways to store the information in our daily life, such as writing notes in a notebook, saving files in a folder, or storing contacts in a mobile phone. AI also has different methods for organizing and storing the knowledge. These methods are called knowledge representation techniques or approaches. Some of the popular techniques includes logical representation, semantic networks, frame representation, production rules, ontology. So here we are going to study each of these techniques one by one. So let's begin with to begin with, let's understand one of the simplest and most widely used techniques called production rules. So what are production rules? Production rules are based on a very simple idea. They follow the format. If some condition is true, then perform an action or conclude something. So you can think of them if then statement. Interestingly, we use production rules in our daily life all the time, even without realizing it. See, for example, if the traffic signal is red, stop. If the phone battery is below 20%, then charge it. If room is dark, then switch on the light. So these are some of the examples of production rules. Similarly, AI system also uses these if then rule to make decisions. Let's look at one of the example is if the sky is cloudy. Okay, if the sky is cloudy, then it may rain. This means whenever the AI detects that the sky is cloudy, it concludes that the rain is possible. Now look at the second rule. If it may rain, then carry an umbrella. This means if there is possibility of rain, the AI recommends carrying an umbrella. Now imagine that today the AI receives the information from a weather sensor that the sky is cloudy. The AI checks its stored rules. First, it matches the condition, the sky is cloudy, so it activates the first rule and concludes it may rain. Now, this newly inferred fact becomes another input, and the AI again checks its rule. If it's If it finds the second rule, if it may rhyme, then carry an umbrella. Finally, the AI concludes carry an umbrella. So notice something interesting here. Nobody directly told the AI to carry an umbrella. The AI reached its conclusion by applying multiple rules step by step. This process is called inference or reasoning. So why are production rules powerful? So production rules are extremely useful because they allow AI system to solve problems by applying logical rules. As more rules are added, the AI becomes capable of handling more complex situations. For example, in a medical diagnosis system, the rules might look like this. If the body temperature is 38 degrees Celsius, then fever. If fever and cough are present, then possible viral infection. If viral infection is suspected, then recommend a medical test. So, by applying these rules one after the other, the AI assists doctors in making better decisions. Similarly, production rules are widely used in expert system, medical diagnosis, banking system, customer support chatbot, and industrial automation. Okay, so next, the thing. So, in real life analogy, if you want to say, think of a production rules like following the instruction in the recipe. For example, if the water starts boiling, then add a rice. If the rice becomes soft, then turn off the stove. So now that we have learned how the knowledge is stored inside an AI system, the next important question is, once the knowledge is stored, what does the AI do with it? The answer is reasoning. So reasoning is the process by which an AI system uses its existing knowledge to draw the conclusion, discover the new facts, or make decisions. Think of reasoning as the process of an AI system. Just like humans don't just memorize facts, we also use those facts to solve problems. AI does exactly the same thing through reasoning. See, for example, imagine our phone's weather app tells that heavy rain is expected today. So we immediately think if it's going to rain, I should carry an umbrella. Nobody explicitly told that to carry one at that moment. You used your existing knowledge, or we used our existing knowledge to make a logical reasoning. This process is called reasoning. And in artificial intelligence, there are three major types of reasoning. The first one is deductive reasoning, second one is inductive reasoning, the third one is abductive reasoning. So let's understand each one with simple examples. The first one is deductive reasoning. The first one is deductive reasoning. So this is probably the easiest understand because it follows strict logic. It starts with a general rule and applies it to a specific situation to reach a conclusion. In other words, general rule is a specific fact and it leads to conclusion. So let's take a classic example. Suppose we know all humans are mortal and Ramesh is a human. What can we conclude? Obviously, Ramesh is immortal. This conclusion is always correct because it is based on a logical rule. That's why deductive reasoning is considered highly reliable. So AI system use deductive reasoning in expert system, rule-based system, mathematical proofs, automated reasoning. So another simple example is suppose the rule says every employee must carry an ID card. Now, we know Priya is an employee, the AI immediately concludes Priya must carry an ID card. This is deductive reasoning. So second one is inductive reasoning. So unlike deductive reasoning, it works in the opposite direction. Right? Here, the AI starts by observing multiple specific examples and then forms a general rule. In other words, specific observation leads to the general conclusion. For example, suppose the AI observes crowd 1 is black, crowd 2 is black, crowd 3 is black, crowd 4 is also black. After observing many crowds, the AI may conclude most crowds are black. So here notice something important. This conclusion is not guaranteed to be true. So there could be still be a white crow somewhere in the world. So inductive reasoning is based on patterns and probabilities, so not certainty. So this type of reasoning is heavily used in machine learning, data analysis, pattern recognition, and predictive analytics. So this is very, very important, inductive reasoning, which is based on the patterns and probabilities. So if you take one more example, suppose a shopping website observes customer A bought a laptop and then purchased a laptop dog. Customer B did the same. Customer C also did the same. The AI learns a general pattern. People who buy laptops often buys the laptop bags. This is inductive reasoning. So the AI discovered the rule by observing many customers. That is nothing but inductive reasoning. So the next come to the objective reasoning. So here the AI starts with an observation and tries to find the most likely explanation. So notice the words most likely explanation. So it doesn't guarantee that the conclusion is correct. It simply chooses the explanation that seems most reasonable. For example, suppose you wake up in the morning and notice that the road outside is wet. So what do you immediately think? It probably rained last night, right? So did you actually see the rain? No. Maybe someone washed the road. Maybe a water pipe burst. There could be many reasons, but the rain is the most likely explanation. That is objective reasoning. So one more example, if you go with the medical diagnosis. So this type of reasoning is widely used in hospital. Suppose a patient has fever, cough, body pain. The AI may suggest the patient may have a viral infection. Notice that AI is not saying the patient definitely has a viral infection. It is simply providing the best possible explanation based on the available symptoms. So doctors then perform additional tests to confirm the diagnosis. That's why objective reasoning is very popular in medical diagnosis, fault detection, cybersecurity, and also in troubleshooting system. So if we compare all the three types of knowledge representation or reasoning in knowledge representation, so deductive learning starts with a general rule and arrives at a certain conclusion. So inductive reasoning starts with many observations and create a general rule. And objective reasoning starts with an observation and finds the most likely explanation. Deductive gives certainty, inductive gives probability, and objective gives best explanation. Okay, so the next one. Some of the real world examples of care systems are medical diagnosis, okay, so natural language processing and robotic search engines. Okay, so in medical diagnosis, expert system like Mycin and natural language processing is also says semantic networks for understanding sentences and robotics here. It knowledge graphs to plan the movement and search engines, knowledge graphs by Google. Okay, so these are some of the real world example of care system. So in short, knowledge representation is the foundation of artificial intelligence. It helps the AI to understand, reason, and decide just like the human mind. So the next one is knowledge-based agent. It's also called as KBA. Okay, so one of the best example of a knowledge-based agent is KBA, often called KBA. The next topic is knowledge-based agent. In simple word, it is also called as KBA. Now that we have learned about the knowledge representation and different types of reasoning, let's see where these concepts are actually used in artificial intelligence. So one of the best example is knowledge-based agent, often called KBA. Before understanding the definition, let's first think about how humans make decisions. Imagine you are driving a car. You reach a traffic signal. You see that the signal is red. Immediately, our brain recalls the rule: if the traffic signal is red, I should stop. Based on this knowledge, you press the brake. Notice what happened. You didn't stop randomly. You first used your knowledge and then reasoned and finally took an action. A knowledge based agent works exactly the same way. It doesn't act blindly. Instead, it first looks at what it already knows, think about the situation, and then makes a decision. That's why it say a knowledge based agent is an AI system that reasons and acts using the knowledge base. A knowledge base is simply a collection of facts, rules, and information about the world. Whenever the agent receives the new information from its surrounding, it compares that information with its knowledge base. Then it applies the logical reason to determine the best possible action. So this makes the agent intelligent because it doesn't simply follow the fixed instruction. it can make the decisions based on the knowledge it has. So how does a knowledge-based agent work? So let's understand the working of a knowledge-based agent step by step. So the first step is, so it's going to observe the environment. So the agent collects the information using the sensors or receives the input from the user. See, for example, a weather app detects the sky is cloudy. A chatbot receives a customer question. A self-driving car detects a red traffic signal, and this information becomes input to the agent. So second step is store or access the knowledge. So the knowledge, so the knowledge base may contain rules like if the sky is cloudy, it may rain. If it may rain, carry an umbrella. If the traffic signal is red, stop the vehicle. These facts and rules are already stored inside the system. So the third step is perform the reasoning. So now comes the most important part. The agent applies logical reasoning to the stored knowledge. Suppose it observes the sky is cloudy. It checks the first rule. If the sky is cloudy, then it may rain. So the AI conclude it may rain. Now it checks the second rule. If it may rain, then carry an umbrella. Finally, the agent concludes carry an umbrella. Notice that nobody directly told the AI to carry an umbrella. The AI reached this conclusion by reasoning with the knowledge stored in its database. The fourth step is take action. Finally, after reasoning, the agent performs an action. Fourth step is take action. Finally, after reasoning, the agent performs an action. For example, recommend carrying an umbrella, answer the user's question, stop a self-driving car, suggest a medical diagnosis, recommend a product on e-commerce website. So the complete cycle is observe, think, decide, and act. So this is exactly how the knowledge-based agent works. In another example, if you say, imagine a doctor enters the following symptoms into an AI system. So what are those symptoms? Either it may be a cough, fever, body pain. The knowledge base contains medical rules such as if fever and coughs are present, possibly viral infection. If viral infection is suspected, the recommended is a blood test, and AI reasons through these rules and suggest the patient may have a viral infection, a blood test is recommended. Again, the AI system didn't guess randomly, it used its stored knowledge and reasoning. So the next one is components of a knowledge-based agent. So you can think of a knowledge-based agent like human brain. Our brain has two major responsibilities. First, it stores the knowledge such as facts, experience, and rules that we have learned over time. Second, it uses that knowledge to think, reason, and make decisions. Similarly, a knowledge-based agent works in exactly the same way. It may consist of two important components. The first one is knowledge base. Knowledge base. The second one is inference engine. So let's understand each one in detail. So the first component is the knowledge base, often abbreviated as KB. As the name suggests, this is where all the knowledge is stored. Think of it as a memory of the AI system, just like our brain stores the information. So we have learned in school or from experience. The knowledge base stores everything the AI knows about the world. So this knowledge can include facts, rules, relationship, concepts, objects, events. In short, everything the AI needs to make intelligent decisions is stored inside the knowledge base. So if you take an example, so let's look at the example shown here. The knowledge base contains two simple rules. Rule one is if it is raining, then the ground is wet. And if the ground is wet, then drive carefully. These rules are stored in the knowledge base. Notice that the AI is not thinking yet. It's simply storing the information that may be useful later. The knowledge base acts just like a digital encyclopedia or a library where information is organized for the future use. How is knowledge stored? Now you may wonder, how does the AI actually store this knowledge? It doesn't store it in it as a plain English paragraph. Instead, knowledge is stored using a special knowledge representation language. So some common techniques include logical representation, product rules, frames, semantic networks. Uh, so these techniques organizes the information in a structured way so that the AI can easily understand and process it. So remember, the knowledge base stores the knowledge, but it doesn't make the decision on its own. For that, we need the second component, which is nothing but inference engine. The This is often refers to as the brain. Okay, so inference engine is normally okay, so it's often referred to as a brain or the thinking part of knowledge based agent. If the knowledge base is like a library, then the inference engine is like a person who reads the book, understand them, and solve the problem. Its job is to examine the stored knowledge, applying the logical rules, and derive the new conclusion. This process is called inference. So let's example. So if you take one example, the AI receives the new information like it is raining. Now the inference engine starts thinking. It checks the knowledge database or knowledge base and finds the first truth. If it is raining, then the ground is wet. So it concludes the ground is wet. Now it doesn't stop there. It again searches the knowledge base and finds another rule. If the ground is wet, then drive carefully. Now the AI reaches its final conclusion, drive carefully. Notice something interesting. Nobody directly stored the statement drive carefully because it is raining. The AI discovered it by applying the logical reasoning step by step. So this is exactly what the inference engine does. So working together, so these two components always work together. The knowledge base stores the information, the inference engine uses that information to think and make decisions. Without a knowledge base, the AI has nothing to reason with. Without an inference engine, the AI has knowledge but cannot use it. Both components are equally important. The next is working of a knowledge-based agent. Now that we have understood the two main components of a knowledge-based agent, the one is knowledge base, another one is the inference engine. Let's see how these components work together to make intelligent decisions. So you can think of a knowledge-based agent as the following simple cycle: observe, think, learn, act. So let's go through each step one by one. The first step is perceive the environment. Okay, so here, just like humans uses their eyes, ears, and other senses to understand what's happening around them, an AI agent also gathers the information from its surrounding. This information can come from sensors, cameras, microphones, or user input. Either it may be from database or it may be from internet services, etc. See, for example, imagine a self-driving car. Its camera detects that the traffic signal has turned red, or think of a weather application. It receives live weather information and detects that the sky is cloudy. Similarly, a chatbot receives the question typed by the user. This is the first step, collecting information from the surroundings. The second step is update the knowledge base. So once the agent receives the new information, it doesn't immediately make a decision. Instead, it first updates or checks its knowledge base. The knowledge base already contains the facts and rules about the world. For example, it may already know if the sky is cloudy, it may rain. If the traffic signal is red, stop the vehicle. If the body temperature is above 38 degrees centigrade, the patient has a fever. Now, suppose the weather sensor report the sky is cloudy, the knowledge base stores this as a new fact. Similarly, if the traffic camera detects a red signal, that information is also stored. So this ensures that the AI is always working with the latest information. The next step is use the inference engine. Now, okay, so the inference engine starts thinking. So it examines the facts stored in the knowledge base and applies the logical rules. Let's use the weather example. So the knowledge base contains these rules. If the sky is cloudy, then it may rain. If it may rain, so then carry an umbrella. The agent has already observed that the sky is cloudy. The inference engine checks the first truth and concludes it may rain. Now, this newly inferred fact is used again. The engine checks the second rule. Since it may rain, it concludes carry an umbrella. Notice that nobody directly stored the sentence carry an umbrella, right? So the AI approached this conclusion by applying in logical reasoning. So this is exactly what the inference engine is designed to do. The fourth step is choose an action. So after reasoning, the AI decides what action should be taken. So this is called action selection. So depending on the situation, the action could be display a recommendation, send a warning, stop a vehicle, turn on an alarm, answers the user's question. In our other example, so the chosen action is recommended carrying an umbrella. In a self-driving car, the action could be apply the brake. In a medical diagnosis system, the action could be suggest a blood test. If the cough and fever has, okay, if the person is having cough and fever. So after thinking, the AI finally makes the decision. So after thinking, the AI finally makes a decision. The step 5, execute the action. So the final step is to perform the selected action. This is where the AI interacts with the real world. See, for example, a chatbot displays the answer on your screen. Google Maps suggests an alternative route. A robot picks up an object. A self-driving car slows down, and a smart home system switches on the lights. The action depends entirely on the conclusion reached by the inference engine. So now that we have seen how a knowledge-based agent works with a real-world example, let's discuss its strength and limitation. Like every technology, knowledge-based agents have many advantages, but they also have some challenges. Understanding both sides helps us to know where these agents are most useful and where they may need additional technologies. Okay, so first let's talk about the advantages. So the advantage of knowledge-based agent is can explain its reasoning. Okay, the first one is can explain its reasoning. Okay, so this is one of the biggest strength compared to many modern AI models. So, for example, suppose a medical AI recommends that a patient may have viral infection. If the doctor asks, "Why did you come to this conclusion?" So the AI can explain its reasoning step by step. So it may say the patient has a fever, the patient has a cough, and according to the rule 5, fever and cough together indicate a possible viral infection. So unlike a black box system, a knowledge-based agent can show the logical path is followed. It followed. So this makes the system more transparent and trustworthy. The second one is flexible and adaptable. So the second one is flexible and adaptable. The second advantage is that the knowledge-based agents are easy to update. So the world keeps changing. So new laws are introduced, new diseases are discovered, and business policies are updated. Instead of rebuilding the entire AI system, we simply update the knowledge base by adding or modifying the rules. See, for example, suppose the weather department introduces a new warning level, we simply add a new rule to the knowledge base and the agent immediately starts using the updated knowledge. So this makes the system highly flexible. So the next one is reusable knowledge base. The third advantage is that the same knowledge base can often be reused for similar application. See, for example, suppose a hospital develops a knowledge base for diagnosing common diseases, another hospital can use the same knowledge base with only a minor modification. Similarly, a banking knowledge base can be reused across the different branches. So this saves both time and development effort. The fourth one is can make intelligent decision in new situation. So here the fourth advantage is that knowledge-based agent can handle the situation they haven't seen before. How is this possible? Because they don't simply memorize the answers. Instead, they use the logical reasoning. For example, suppose a weather agent has never encountered today's exact weather conditions before. Even then, it can combine different rules and arrive at a sensible recommendation. So, this ability to reason allows the agent to solve new problems instead of just repeating the stored answer. So next come to the limitation of knowledge-based agents. So what first one is the complex to build for large domain. So the limitation is that the building a knowledge base for a very large domain can be extremely difficult. Think about creating an AI system for an entire hospital. You would need thousands of medical rules covering hundreds of diseases, treatment, medicines, and exceptions. Writing all those rules manually takes enormous time and effort. As the domain grows, maintaining the knowledge base also becomes more challenging. The second one is reasoning can become slow. So here, when the knowledge base contains only a few rules, the inference engine works very quickly. But imagine a system containing millions of rules. The AI has to search through a massive amount of information before finding the correct truth. As a result, reasoning may become slower. This is one reason why optimizing inference algorithm is an important area of AI research. The third limitation is requires accurate and consistent knowledge. So here, if the stored knowledge is incorrect, okay, if the stored knowledge is incorrect or incomplete or contradictory, the AI will also produces incorrect conclusion. So there is a popular saying in computer science: garbage in and garbage out. If we produce a poor quality knowledge, we cannot expect intelligent decisions. Therefore, maintaining an accurate and consistent knowledge base is extremely important. The next limitation is difficult to handle uncertainty. So here the real life is not always black and white. Sometimes information is incomplete or uncertain. For example, a patient has a mild fever. Does that definitely mean they have a viral infection? Not necessarily. Simply, a dark clouds. Similarly, so dark clouds may indicate rain, but sometimes it never rains. So traditional knowledge-based agent works best with the clear logical rules. Handling uncertainty often requires additional techniques such as fuzzy logic, probability, Bayesian networks, machine learning. So these techniques help the AI make decisions even when the information is uncertain or incomplete. So this completes about the knowledge representation system. So we'll see with the next module. Thank you.